Hello everybody, Orbax here. So I promised to answer the questions that you had about science and day-to-day life. We're trying to make the most that we can out of this isolation that we're all under right now. And so we got quite a few questions that came through and people asked. And one of them that we thought was really good is, why do things bounce? So to understand the idea of bouncing, there's two major things that I wanted to talk about. One is this idea of Newton's third law, and the second is the idea of something called elastic deformation. So let's start with elastic deformation. Now, certain materials are rubbery or elastic in nature. Something like, say, this basketball, right? Now this basketball has an optimal shape, in this case the sphere, and the molecules, when they're in this shape, actually have a preferential desire to stay in this shape. It's the least amount of energy to stay like this. Now when I push this in like this, you'll see that there's a deformation that occurs, right? Now the fact that this actually bends in, and when I release my thumb, comes back out, is this idea of elastic deformation. What happens is that nothing in the world wants to have more energy than it otherwise needs to have. And so what it'll do is it'll always return to a state of the lowest energy. This is a certain amount of energy. To put power, to put force, to put energy into it to change its shape causes it to be in a higher energy state. And as soon as I release it, it goes back out into its lowest energy form. Now, pretty good, eh? Wait for it. I'm sure none of this is actually on camera. That's pretty good. So, when something like this hits the ground, it didn't really bounce at all there. When something like this hits the ground, the deformation that's caused in the side creates this sort of dent. And it actually wants to spring back to the shape that it originally was in. On a molecular way, you can think about it as in the molecules have this preferential orientation that they want to stay in. As soon as you deform it, the amount by which it can spring back into its original shape is a measure of its elastic deformation. Materials like, say, an egg have a very low threshold for that. If you push the side of an egg, it will take the energy that you're putting into it and it'll actually break the structure of the egg itself. Whereas something like this has this ability to stretch or to compress and still spring back into its normal shape. When I take this object and I drop it and it bounces back up, at that point of impact, the deformation has stored energy in it and will actually push that energy back out to retain its original shape, and that creates a springing sort of sensation. The fact that it compresses and then wants to go back to its original shape will actually force it into that shape, and that's a little bit of what happens in a bounce. Now the other part that I talked to you about was this idea of Newton's third law. Now you've probably heard Newton's third law said before, for every action there's an equal and opposite reaction. And that's kind of a naive way to think about it. The way it was originally written was such that for every force A acting on B, there's a reaction force from B that acts on A. Think about this in terms of your weight. You're standing on the ground and you feel the ground pushing back on you. You're standing there and you weigh a certain amount due to your mass. The force of gravity pulls down onto the earth, but you don't actually feel the force of gravity pulling down on you. What you feel on your feet is the force of the earth pushing back against you with the same weight, equal and opposite reaction forces. So if I take an object like this baseball and I take it and I drop it down on the ground, it puts a force on the ground when it strikes the ground. Now that force has to do with the mass of the ball, how heavy it is, its size, what have you. When it strikes the earth pushes back up against the ball. And it's the pushing back up against the ball that bounces that ball back up into the air. Same thing happens with this basketball. If I take this basketball and I drop it down, there's a force when the ball hits the ground, and there's a force in the ground that pushes the ball back up in the air. Both of those factors together actually help or actually go towards making a ball bounce. So, to elucidate this, I want to show you a little experiment that you can do at home. I've got a big ball and I've got a small ball here. And so I'm going to go out in the hallway and set this up so you can actually see how we're going to do this. All right, we'll see how this works. Probably not too well. Okay. So, I've got two separate balls here, right? First of all, I've got a baseball. If I drop this baseball, let's see how it bounces. Now, not much of a bounce. The ball itself actually has a low mass, and you'll notice it doesn't actually deform very much when it hits the ground. It's really hard, and so that deformation doesn't add to the spring to it. We'll also take a look at this basketball. Now, the basketball also doesn't bounce really well, and that's for two reasons. One is that it's a big, heavy basketball, but two is it's actually not very inflated. It's not really that springy, so it doesn't add as much bounce to it as it really could. Here's the question. I'm going to drop these two on top of each other, and I want you to figure out what's going to happen. So, do you think that the ball, I drop them like this, do you think that the balls are going to bounce the same? Do you think that the balls are going to bounce higher? Do you think that the basketball is going to bounce and that this one won't? I want you to go into the comments below and post what you think is going to happen and tell me why, and we'll do a follow-up tomorrow. So here we go. Ready? Don't forget to post below.